Hello students, in this video basically I will discuss about resistance. As discussed in the previous video, with the help of Ohm's law we have understood that there is used one proportionality constant, that is only resistance, denoted by capital R. We will study about resistance, then on what factors does the resistance of a conductor depends on, then resistivity, what is resistivity, what is the resistivity of various types of substances, then what type of circuit will be found when the resistances are connected in series, and what type of circuit will be found when the resistances are connected in parallel, what will be the mathematical relation of parallel and series connection of resistances respectively, various types of applications or advantages of parallel combination and series combination of circuitry, then heating effect of electricity, what is actually the mathematical relation of heating effect of electricity or electric current, then at last we will study about electric power. So let us start understanding about these terms one by one. Resistance, as I have told that in Ohm's law, when V is directly proportional to I, then replacing this proportionality constant we need to use some replacing this proportionality symbol we need to use some proportionality constant, and that is R, which is actually resistance. It is the property of a conductor that resist the flow of charges through it. So resistance is the property of conductor through which it is capable of resisting, means opposing it. It don't allow current to flow through it, and that's why I have told that resistance is inversely proportional to current. Means where there will be more current there will be less resistance, or where there will be more resistance there will be less current. Next is the SI unit of resistance is actually ohm. It is written here, its symbol is like this. 1 ohm is equal to 1 volt upon 1 ampere. Means if we are writing R is equal to V is equal to IR, we know that, and if we are writing R is equal to V by I, then V is according to units, V is unit of V is volt and unit of current is ampere, so it will be ohm. Means 1 ohm is equal to 1 volt upon 1 ampere. When potential difference of 1 volt and current through the circuit is 1 ampere passes through the circuit, or when 1 volt potential is produced, generated or induced in the circuit such that the current of 1 ampere flows, that amount of resistance is said to be 1 ohm. This is important to remember for you all. Next is rheostat. I have used this term in the previous video. So variable resistance is a component used to regulate current without changing the source of voltage. Means without touching any source of voltage, when current is changed, the instrument with which we are able to change the value of current is actually rheostat. That's why it is called variable resistance. Variable means continuously changing. That change of resistance means whenever we will regulate the current, where resistance will also be changed. So that device is actually rheostat. Next is factors on which resistance depends. It is length of a conductor inversely proportional to the area of conductor. It depends on length, resistance depends on length, area and temperature and nature. How it is proportional to length means length. How it is dependent on length? It is directly proportional to length. How it is dependent on area? It is inversely proportional to area and directly proportional to temperature, and depends on the nature of material, whether it is solid, liquid or whatever type. If it is heating, then its nature will be something else. So depends on same that type of nature. Then it is resistivity. It is actually defined as the resistance that is offered by cube of a material. Cube you all know is like this. If in this type of material, if side is of 1 meter, then when current flows perpendicular to its opposite faces, current flows when opposite faces in this phase and in this phase, then that is defined as resistivity. Or by mathematical relation we may understand that rho is equal to R into A by L. This is actually resistivity, means resistivity is actually the resistance of that conductor whose length is 1 meter and area is 1 meter square. That is resistivity. Its unit is ohm meter. The unit of resistance is resistivity is ohm meter, while the unit of resistance is ohm. Resistivity does not change with change in length. Means resistance used to depends on length and area, while resistivity never depends on length and area. It never depends on length and area, but it changes with the temperature. I mean, it depends on the temperature, and also it may be depend on the nature of the substance or wire or conductor. So resistivity depends on temperature and nature, while resistance depends on length, area, and as well as on nature and temperature also. Range of resistivity for metals, this you have to remember. It is ranging from 10 to the power minus 8 to 10 to the power minus 6 ohm meter. Next is in insulators, it varied from 10 to the power 12 to 10 to the power 17, while in alloy it is generally higher than that of any other metals. That's why various types of alloys are preferred in making various types of electrical appliances. Alloy do not oxidize readily at high temperatures, so they are commonly used. This is also the reason why alloys are preferred in making various types of electrical appliances. These 2 points you have to remember. One of the 2 common and cheap, you can say cheap type of elements in our periodic table which are used for making electrical transmission lines are copper and aluminium. These are preferred in much more quantity. Then if these resistances are connected such that the tail of one resistance is connected to the head of, means tail of one resistance is connected to the head of another resistance, again tail of another resistance is connected to the head of, then at that type of circuit we are used to say it series combination. This is the actually zigzag type is the symbol of resistance. This is actually resistor in which one resistance is being connected to another resistance by connecting their head to tail and head to tail like this. And I have told in the previous video that for finding current, galvanometer must be arranged in the series, and that's why ammeter also is arranged in series, while voltmeter is always arranged in parallel. It is parallel. Next is the formula for finding series resistance is this. Rs is equal to, means R series is equal to combination as sum of their individual resistances. Next is parallel. In parallel, head of one is connected to other, head of other is connected to the next one, and tail of one is connected to next one, and tail of next is connected to, here heads have been connected, here tails have been connected, and voltmeter again is in parallel combination while ammeter is in series. So you have to remember that ammeter is always connected in series while voltmeter is connected in parallel, while galvanometer when it will be connected in series, it is going to measure current, and when it will be connected in parallel, it will going to be measuring voltage. Now let's move to see the relation between parallel combination, that is 1 upon R1 plus 1 upon R2 plus 1. How many number of resistances are connected will be given like this, means reciprocal of individual resistance, sum of reciprocal of individual resistances. Then what is the advantages of parallel and series combination? Which circuit is preferred in our houses? So parallel is much more comfortable than series in our houses. Series circuit, when one component fails, the circuit is broken, none of the component is going to work. While in parallel it is not like that, because in parallel voltage remains same, in parallel V remains same, while in series I is same in series circuit. This you have to remember. I is same in series and V is same in parallel. At our domestic circuits we use parallel circuit, because it is not like that if our fan stops working then whole of the electricity of our house will stop working. It is not like that. That's why parallel combination is used in our circuit, means the total resistance in parallel circuit is decreased while the total resistance in series circuit is increased. So next topic is heating effect of electric circuit. It was given by actually Joule, who was one scientist. According to Joule, one law was given which was termed as Joule's law of heating effect. Joule's law of heating effect of electric current. Let us understand what is actually heating effect of electric circuit. Actually, whatever will be the heating effect of electric circuit will be the heating effect of electric current. You have studied in your previous classes that there are various types of effects shown by electric current, that is chemical, magnetic, and this is one more type of heating effect, that is that one more type of effect shown by electric current, that is heating effect. If any of the electric circuit is purely resistive, the source of energy is continually getting dissipated, means it is being lost, means if energy is being lost entirely in form of heat you know is a form of energy. If in any circuit current is flowing and at that time if there is some dissipation of energy which will be in the form of heat, this heat is actually known as heating effect of electric current, or this type of effect when shown by any circuit will be termed as heating effect of electric current. Energy is equal to, here it is written, P into T, which will be directly proportional to VIT. Now if energy consumed will be considered as heat, it will be equivalent to, means H will be equivalent to VIT, where V we know that is equal to IR according to Ohm's law. Putting the value of V in place of V here, we have got H is equal to I square RT. With this relation only, Joule concluded that the heat produced in the circuit will be directly proportional to the square of the current, will be directly proportional to the resistance that will be present in the circuit, and will be directly proportional to the time for which current flows through the conductor. These all things are actually in any conductor we are talking about. Next is heating effect is desirable in various types of devices. In various types of devices, different types of heating effect can be seen. Like we are having example of electric iron, means in television, in fan also you might have seen that after long use, each of these things start heating. They are actually showing what dissipation of energy, and that energy is actually in the form of heat. Next is here power. What is power? Power in context to electricity, if you are studying, then that power is said to be electric power. It is actually the rate at which electrical energy will be consumed or dissipated in any electric circuit. Means with respect to time, rate means with respect to time, whatever amount of energy will be dissipated by any electric circuit will be defined as electric power. There are two relations which are very much important. P is equal to IV, then P is equal to I square R, and P is equal to V square by R. These three relations are very much important, and if you will go through the mathematical relation according to this definition, it will be power is equal to work done upon time, which is actually energy consumed upon time. So this is actually where W can be taken as electrical energy. Then we can write that power is equal to W by T, power is equal to VI, power is equal to I square R, power is equal to V square by R. Each and every relation is very much important. The SI unit of power is watt. Various types of units have been told in this chapter, and you have to remember each and every unit. 1 watt, if you are asked to define 1 watt, it will be defined as 1 volt into 1 ampere. What is the commercial unit of electric energy, or we can say power? It is kilowatt hour. 1 kilowatt hour, this relation is very much important, that is 3.6 into 10 to the power 6 joule. This relation is very much important. 1 kilowatt hour is sometimes also known as 1 unit of electric energy. So this was all about your heating effect of electric current, electric power, and before I have told resistivity, how resistance depends on length and area, on what factors resistivity depends on. Each and everything have been told you, and now it's needed to do practice. Thank you, students.